Hey everybody, let's take a look at balancing redox reactions that are catalyzed by bases. So the way that, and you can write down these steps, they're going to be very similar to acid catalyzed reactions. If you've looked at those, the only difference is going to be, as we look at this, it's going to be this guy right here, okay? And so keep in mind that redox reactions sometimes need either acid or base to be to move forward to start that electron cascade, that electron movement that's characteristic of redox reactions. So let's go over how to balance base catalyzed. Let's do a little reaction here, base catalyzed reaction. Let's do a sample. Let me move my microphone to a place that, okay, good. Ha. Okay, so the first thing we want to do is we want to determine what's being reduced and what's being oxidized. So here's aluminum. Anytime I see a metal that has that's all alone and has no charge, then over here I can tell you that aluminum has a 3+ charge. So I know that this is being oxidized. Okay. Now if we see here, so when I see something that has a 0 charge, an element in its natural state, standard state, then I know that it's probably the thing that's being oxidized or reduced. And so now over here, hydrogen, this oxygen has a 2- charge most of the time, so this is going to be a 1+. So this guy is going from 1+ to 0, so this guy is being reduced. Okay, so let's take a look and see what happens here. So we've identified what's being oxidized and reduced. When we do this, that allows us to split it into the half reactions. Okay, so the oxidation half reaction is going to be aluminum, solid. You know what? Just to save space, I'm going to avoid doing that. So aluminum reacts to form this bracket aluminum hydroxide. We use brackets there, just so you know, just because we've already used parentheses. Okay, and then the reduction half reaction. Okay, the reduction half reaction is H2O reacts to form H2 gas. Okay, so now we follow our steps. Okay, so we balance everything but hydrogen and oxygen. Okay, everything but hydrogen and oxygen are balanced. Now we balance oxygen using water. So here are our 4 oxygen atoms here. So we're going to put 4 H2O here. And actually, you know what I'm going to need to do is I'm going to need to get rid of those labels there. Okay, 4 H2O. So that's 4 O's and 4 O's. And now here we need to add 1 H2O. Okay, now we balance using we balance the hydrogens using H+. Now this is our placeholder. We understand that this is a base catalyzed reaction. So what we're doing is we're just using hydrogen to get us to the number of hydroxides, and I'll show you how that works in a minute. But this is 8 hydrogens. 4 times 2 is 8. This is only 4 hydrogens, so we need plus 4H+ here. Okay, and so now let's see, we have 4 hydrogens here, 2 hydrogens here, so we're going to do plus 2H+ there. And so now this is the trick here, is that now we're going to use hydroxides to cancel out the hydrogen ions. Okay, but we've already balanced this. We've already balanced this half reaction. Okay, so if it's already balanced, when we add hydroxides, we want to add it to both sides so that the balance isn't messed up. Okay, so this is going to be, so if we have 4 H+, we want to cancel all those out by putting 4 OH-, but if we do it to this side, we have to do it to this side, 4 OH-. Now, what happens here to 4H+ and 4 OH-? These two things turn into 4H2O. Okay, remember H plus and OH minus, they're water. Okay, so now we can do the same thing here. We have 2H plus, so we're going to do 2 plus 2OH minus, hydroxide minus, but if we do it to this side, we have to do it to this side. And so this was 2OH minus. Now this just like in the previous half reaction, this becomes 2H2O, and now life is good. Okay, so now we've catalyzed this with base. Notice there's no H plus left. Okay, so now what we have to do is we have to make sure we balance the charge. Okay, so this is what ends up happening. We balance the charge using electrons. Okay, so this is 4 minus. This is only 1 minus. So we need to have plus 3 electrons on this side. So if there's plus 3 electrons, okay, on the product side, let's see, it's being produced, so it's losing electrons oxidation. Okay, so far it fits. I'm doing some internal checks as I go along here. Okay, and so now let's see here. We have neutral, okay, H2O and H2O. And then here we have 2 minus, so we have to put 2 electrons on this side. Okay. Now, notice 3 and 2, so that means that in order to get this to cancel out, we're going to take this and we're going to multiply this reaction by 3, and we're going to take this reaction and multiply that by 2, because 2 times 3 is 6, 3 times 2 is 6. So the number of electrons being lost by the oxidation half reaction is the same number of electrons that's being gained by the reduction half reaction. So the number of electrons cancel out, but that coefficient of 2 stays there. Okay, so now let's bring down all the reactants. Let's see, so this is 2 times 4 is 8, 8OH minus plus 8H2O plus, let's see, whoa, hey, plus 2Al plus the, let's see, here's an H2O and here's an H2O. There's 2, so that's 3H2O. Oh, but wait, it's times 3, so this is actually 9H2O, reacts to form. Okay, so 2ALOH, and square brackets because we've already used the parentheses in there. 1 minus plus 8H2O, because 2 times 4 is 8. And now down here we have 3, so plus 3H2, 3 times 8, 1 is 3, plus 3H2O plus 6OH minus. Okay, so now what I've done is I have combined all these. So what I'm going to get rid of this here. Okay, and so by getting rid of all this, I have now a lot of room to write. Okay, so now let's see, so 8 and 9, so this is the last thing we have to do, is we have to combine by combining and canceling things. Okay, so let's start with our waters. So this is 8 and 9, this is 17 waters. So right now we have 17 H2Os on this side. Here we have 8 H2Os. All of these are going to cancel out, and 8 are going to cancel out. This is going to give us 9 H2Os. Now if we look, we also have hydroxides on both sides. Okay, so if we look here, all 6 of these are going to cancel out, and this is going to go down to 2 hydroxides. Okay, so now if we're going to rewrite this reaction, it's going to be 2OH minus plus 9H2O plus 2Al reacts to form. Okay, 2 parentheses, bracket AlOH4 1 minus plus 3H2O 2 plus, oh look, I forgot this H2O. Oh man, so I'm going to get rid of that H2O. And so now we're down to 6 H2O here. So it's not plus anything else. Okay. So I think that that is the balanced chemical reaction. Double check, the easiest way to double check. When we double check, check charge. So what's the charge of the reactant side? This is 2 minus. What's the charge of the product side? 2 minus. So this is 2 minus. This is 2 minus. Checks. Okay? So that's how we balance reactions in base catalyzed redox reactions. Have a great day, everybody.